What happened to the tricycle? Your mom take it away?
Look, I'm out of here, pal. Get in or get lost.
Fine, as long as I'm back by the next ice age. So, you want me to get behind and push?
No, I want you to get in front and pull.
How fast does this go, anyway?
Real fast.
What's that for?
I don't know. I lost the manual.
Hey, I think a glacier just passed us. Wake me up when we start moving, man.
Oh, not fast enough for you, huh?
I've seen Mercury move faster than this, pal.
I'll show ya.
Hi, my name is Greg Rostami, and this is Will Benton's Playmation. Playmation is a spline-based modeler, animator, and renderer for the IBM, the Amiga, and for Macintosh computer platforms. The module that I'm going to first start showing you today is called Sculpture, and this is where all the 3D models are designed in Playmation. First, I want to show you how easy it is to make a model. Up on the upper left-hand corner of the screen, I can select the button to add a line, and we have a rubber band line on the screen. If I need to add to the end of the line, we just click on a button again and add to the end of the line, and once again to finish off the line. I'm currently working on making a cross-section of a vase. Notice that the points that are running through the lines are represented by splines. What I mean by a spline is that they're not just, straight lines connecting things together. They're curved. I can tweak the curvature of the lines to massage it to the kind of shape that I want. After I got the shape that I'm looking for, I can select my lathe button to get the shape of the vase that I need. Selecting turn, I can turn the model down a little bit and ask the computer to give a skin over the model so we can see how it looks with all the shading applied to it. Now, while this interface is working on the left-hand side, the artist doesn't necessarily have to slow down. On the right-hand side, let's say, for example, we want to select the top of the model and make it a little bit smaller. So we select our bounding box, drag the bounding box around the top, and select our scale buttons to reduce the size a little bit. After we reduced it, I can always move the top cross-section around easily to, again, massage the shape, this three-dimensional shape, into the kind of shape that I'm looking for. After I got that down, let's also put our pivot point up on the top and rotate the model's top around a little bit to get more of an organic shape. So let's see how this looks now. I'm currently using in a demo keyboard equivalents to speed up my interface into Playmation. So beginners will enjoy using the graphical user buttons up on the top, and for every function up on the top, we have a keyboard equivalent to help people access the function more quickly. Now, another thing that I want to do with the shape is go a little bit closer to it and select alternating points and move those down a little bit to get more of an organic shape at the top of the model. Let's see that one more time. Again, while the computer is working on this side, you don't have to stop or slow down. We are using the capabilities of multitasking of the computer to allow us to do many things in the computer at the same time. I've selected the top section of this, and let's extrude that by using our extrude function. So now we have an extra top added to the model. I'll make it a little bit smaller, move it back down, and now we have this little edge at the top of our vase that we didn't have before. Now again, if we want to move continuously, move in the interface, that's still available to the artist. Now, every time a model is made in Playmation, continuously changing the model is an easy thing. For example, we'll select the bottom section, and I want to extrude that, rescale it, to provide a foundation or a base for the model that the model will stand on. Let's extrude it one more time. If I need to do a lot of detail work, I can select just a small area and hide the rest of the model, so I can now just work with the bottom of the vase. Now, I'm going to now bring in a vase, a shape that I've done from before, that is a model of a head, a human head. Once it's loaded in, let's go from a front point of view and rotate the model down a little bit and see how this model looks when it's shaded in. Again, while it's working on this side, let's navigate around in my right view to go closer to the nose of this model to do a little bit of plastic surgery. Okay, let's zoom in a little closer than that. And again, I'll use the bounding box function to draw a box around the tip of the nose. Please notice that I'm working on one side of the environment while the rest is still continuously moving. We just stretch the nose to give the character a nose job. And we go back and straighten up the nose. Please notice again that the surfaces in Playmation are like magic plastic. I stretch it or I squeeze it any way I need to get the kind of shape that I'm looking for. After we got that set, another thing that I want to do to the model is work on a very isolated section. So in this example, I'll select just the nose and the eyes area and hide the other part of the model. What this allows the artist to do is hide everything else that's unnecessary in the frame or in the view so that you can concentrate on just the areas that you want to change. For this example, I want to just select the eye socket and pivot it around a little bit so we can get just a little bit angrier of a character, slanting the eyes down. Once I've done one eye, I'll move on to the other eye. Again, selecting it and selecting my rotation gadget to rotate the eye up a little. After we've made these changes, I can unhide the rest of the model to bring back the back of the head and all the hidden parts that we had hidden before. So let's see what kind of a character we have now by asking for the quick preview. A couple of the other functions in Playmation allow the user to interactively pick up any one of the spline points and move them around while any of the other points that are connected to that point still fluctuate and change. For example, if I wanted to select just the back of the head here and push or pull on it, again, we're using the same analogy of the elastic plastic model to change the interface. Okay. I'm going to clear out this model altogether, and so far we've seen the environment that allows us to create the model. We're going to now jump into the other module of Playmation called Character, in which we can design our attributes of the model. What I mean by attributes is the coloring, the bumps, the transparency. So I've loaded in a model of a picture that I've already made from before. First, let's make the attributes be just a simple blue color. I select my button color gadget, and let's say we select our color controls here to create the kind of blue color that I'm looking for. After I got my blue color set, I will save the model now with those new characteristics. Now, because of the multitasking capabilities of Windows, I can move one module of the program over to the side and bring up our rendering module. The render module is responsible for drawing the shapes that I've created in the sculpture program or that I have textured in the character module of the program. Okay. Now currently the texture that's being rendered on a model is a texture that I had from before, so let's go back and select the blue color that I wanted to use. Okay. again, the blue color. And let's start on this side again with the new render. Now, you can select two different sizes for the render to get either a very quick version of the picture shape being ray traced with the highlights, and we also have a checkerboard ground that's under it. Now, while this is going on, the artist, again, doesn't have to necessarily stop. I can move back here into the interface and start working on another texture that I want to do. Let's say, for example, we want to do a purple and yellow checkered pattern. And I also want to change the size of the checkers, so we can type in a larger size. And after we've made the changes, again, pass these changes across to the rendering module on this side. So now, instead of having the blue picture, I have the alternating purple and yellow texture on the model. Once again, the artist does not have to slow down or stop, because while one program is running, in parallel, any of the other modules of Playmation can be running at the same time. Hence, in other programs that do 3D computer graphics, you're always slowed down by the rendering procedure, whereas in Playmation, you never have to stop being creative. Now, in my sculpture module, I'm going to bring up the picture model that I had before. And let's make a modification to the model surface itself. We want to change how the model looks, not in terms of a texture, but in terms of how the geometry is different. In this case, I want to make the model be just a little bit shorter. Once again, this rendering module is still running in the background. So let's select the model, make it a little bit shorter. And the other thing I want to do with it is, let's say I want to change the nozzle. So we can isolate the nozzle, pull away on it, and now I have a whole new model to work with. Again, I pass the model over to the rendering side and start out a new render. Now you'll notice that we've got a larger nozzle and a smaller model altogether. And if this is too small of a preview, I can stop and ask it to do a larger version of the image so we can see a little bit more detail. Again, while it's working on this side of the interface, I don't have to stop. I can jump back to this side and continue making the modifications to my model. So let's take it back to the way that it was before. Again, bringing back the nozzle and stretching it back out again. Once that's all been set down, we pass it back so that I can have it ready for the next part of my demonstration. Now, the model that is being currently rendered, I'm going to use, once again, for some animation. Playmation was primarily designed around a concept for doing character animation. Now, I have now come into our action module, which we're using, once again, our picture model that I used before. And you'll notice that running through the center of the model, I've placed in this extra line. That line is the backbone of my model. It's very similar to a backbone or a spine that any human or animal would have in the natural world. Now, because we're using an analogy to do character animation, we need to represent how skin or how muscle folds around a certain bone structure that's lying under the body. So this spine that we have on the screen right now is the spine or the backbone of this picture model. First, I tell the computer that that's the spine by assigning it. And then when I move into my spine mode of animating, I can go into, for example, like a right view, and let's bend the model around a little bit. So we'll bend it a little bit to the right, or I can bend it a little bit to the left. Now notice that as I bend the model around, let's say, for example, on the right, the skin fold that's in the lower right-hand corner of the model, the skin folds. Now, of course, the skin has to go someplace because it's in the normal body, skin doesn't disappear. So once we've got this area and we've bent it to one position, I'm going to jump to another frame because this is the area of the program that we're going to do some animation. So I just jump to frame number 30, and let's make another modification. I'll make the model bend back the other way. Now, over on the other side, I can also ask the computer to show me a kind of a three-dimensional view of the model. And on this side, we're also going to select some animation to be done around the neck of the model. So we'll bend the neck down a little this way, jump back to frame 1, and bend the neck around another way. All right. After this has all been set, the computer can give me the interpolation between one frame and the next. So even though I only made a change in frame number 1, and then I made a change in frame number 30, the computer now is filling in all the in-between frames automatically, doing this bending motion from one side to the other. Once this preview is done, we have a display module that allows you to play back all your animations in real time. Notice that in our background, our rendering module is still running. Let's see how that wireframe looks right now. So here is the simple motion as the object bends from one frame to the other. Jumping back into the action module, let's continue doing some more action. All right, now the motion that we did in the action module, if we bring back our display program, you'll notice is kind of mechanical as it bends from one position to the other. The reason why is because we just have a very linear velocity, meaning that like a robot, this picture is just going from one position to the other without really easing in or easing out or changing its speed as it's moving from one frame to the next. Okay? Now what I can do is we need to add in the animator's magic touch. We need to add in the capability so that the program can kind of change the timing as this picture moves from one frame to the other. Jumping back into action, the technology that we invented to do that, to do exactly what I mean in terms of timing changes, we call time channels. Time channel is a simple concept. Now, as you're seeing here, I brought up a little time graph in which the horizontal axis is time. The vertical axis here is representing the tilt around the hip of the model. Now, you'll notice that we got a linear transition. That means that it's going to have just a linear velocity, or it's not really going to speed up or slow down as it moves from frame number 1 to frame number 30. If I want to introduce some change, I just add in any kind of time channel changes I need. So that point that I just added in there has now completely changed the way that this vase here is going to bend from one position to the next. After I've got this down, I'm also going to select the bone that we had around the neck of the model and bring down the channel for that bone. So now we've got two channels on the screen, but you'll notice that the time channel for the neck is completely different for the time channel of the hip, of course, because we need to have different timing controls between the hip and the neck. Now, for the neck, I'm going to do a little bit more complicated of a motion. We're going to have the neck kind of bend back and forth. You'll notice over here, first it's going to bend to one direction. And for the people who are technically inclined, you can read off the numbers over here. It's saying that at frame number 10, it's going to be at exactly 7 degrees. And where it's going to bend back over again on frame number 21, it's going to be 19 degrees of rotation. So you can go in here and fine-tune your rotations for technical purposes of putting in, let's say, exactly 20 degrees of rotation. After that's been done, I'll ask the computer to once again produce a preview. And this time, we're going to get a much more organic and alive animation sequence out of the simple picture shape. Now, time channels is something that we have only found in Playmation. Some of the other programs that do 3D animation only provide you with very linear controls between one frame and the next. They call them in-betweening. Now, with time channels, any kind of time modifications becomes possible now to the animator. Let's see how this animation turned out. Once again in the display module, here we go. As it starts out, you'll notice that it has a lot of speed, but as the hip gets closer to the end, it slows down. Now also notice that the neck is doing that little bend back and forth that I put into the time channel. Now even if the artist doesn't want to really necessarily deal with the controls of understanding what a time channel means, immediately after using it for the first few times, they'll realize the power and the flexibility of having time channel controls. Let's go back to the action module, and I'm going to point out another kind of animation capability built into Playmation called muscle motion. Muscle motion is the feature that allows us to take any point on a model and change it as it animates through time. For example, I need to make this picture kind of bulge its stomach as it's going from one position to the next. So on frame number 1, we pick up the points that are around the stomach, and we bring those down a little bit. Then, again, we jump back to frame number 30, and we're going to bulge out the stomach out as much as we can. Okay? I've made two changes again. Now, the computer can fill in all the in-betweens. This capability allows the animator to be able to add in certain minute changes of either tonal changes on the skin of a model, or muscle bends, or skin changes, or skin wrinkling that again is very hard to do in other pieces of software. Now, each one of these control points also, just like any other point on a model or the spine, has a time channel associated with it. So if I select the control point right at the bottom here and ask it to show me the muscle channel, it tells me that on point number 23, here is the time channel of movement. So each point can have its own timing variations associated with it. So let's see how this animation that we just did right now for the muscle bulging, for the stomach bulging, and for the spine moving back and forth and dancing between its left and right position looks. There we go there. So notice the skin and the muscles right around the stomach are kind of bulging out while the rest of the animation is still continuing doing its work. Okay, you can go a little faster or slower to see less or more detail. Now for the person that's involved with doing a lot of fine detail work on a model, we provide two different modes of having the animation playback. A high-res version, which looks something like this. You'll notice that we have a much higher resolution of our wireframe than what we did before. And a low-resolution version provides the artist with a faster feedback so they can immediately get to see what their timing is going to be like on the model. Let's see how that high-res preview looks. Okay, here's a little quick cut on that with much more detail on the model. All right, the last part of Playmation's design interface is called direction. Direction is a design environment that allows you to bring all your motions together. So first, I'm going to start out just new. And we want to animate an airplane moving across a path. So again, I can go in here and add in a path for my airplane. Immediately after I've established the path that I want of how the airplane is going to animate, I bring in the model that I want to associate it with it. Here's a little biplane. Here's the airplane on the model, on the path. Immediately afterwards, I can start stepping through the frames of the animation, and it shows me that that's the path that the airplane is going to follow. If I need to change the path, I can simply pick up the points, put them someplace else, and now the airplane is going to follow another path. Now we're currently looking down on this airplane. We're kind of in a top-down view. So if I move into a front view, I can have the path move into the third dimension, so the airplane can kind of take off as it's moving from one frame to the next. I can also have the airplane represented by a couple of different ways. I can have it represented by its true spline representation, which means it's going to be drawing in all the curves the way they should be, or a fast vector mode, or even a faster mode than that, which is called bounding box. Bounding box allows the animator to quickly preview the motion that they're working with so they don't have to wait for the redraw times of the more complicated wireframe shapes. So let's also introduce our camera into the environment. Here's by just clicking on a little camera button. And we also want the camera to follow the target. The target is represented by a little green diamond. Click on the target button. And now the camera is going to be following the object as it moves across the path. The two white lines emanating from the green camera, the little green square represents the camera, the two white lines are representing the camera's cone of view. So once we're back, we'll go into a front view, and I'll pick up my camera and move it up a little bit, and ask the computer to show me the object, or the airplane in this case, in its true spline representation. This is now the camera's point of view. Again, just clicking on the camera's object point of view shows me that. And as I start animating across, I can see how the airplane is going to animate across that path from the camera's point of view. Once again, selecting bounding box allows me to do a much faster preview of the motion as the camera sees it. Now, for example, let's say we want this airplane to slow down a little bit as it gets closer to the middle of the path. Again, like the action module, we support time channels even in direction. So this is now the time channel for this path on which the airplane is on. So first of all, we'll select a real simple example of just a linear transition, which is going to just animate from one frame to the next without any velocity changes, without anything slowing down or speeding up. Then I'll add in an extra point in the middle here and extend the point out. So what will happen is as the airplane gets closer to the middle of the path, it will slow down, and then that's actually going to happen on frame 12, again for an exact preview. And on frame number 23, it's going to speed back up again. This is where it picks up its speed and goes to the end. Again, if this timeline here means nothing to the artist, you can, at the same time, click on this preview here, watch how the airplane slows down in the middle, and then continues to go on ahead. Let's do that one more time, but this time in a bounding box representation, so we'll be able to see it a little bit better. Jumping back to frame 1, here we go. Moves forward, slows down, and picks back up its speed. Let's say that we want to do something even more sophisticated. We want the airplane to actually reverse direction. Notice by moving this point down, as it gets to frame number 11, it will go backwards along the path, and then it will pick up the path again and move forward again. Let's try that one more time and see how that timing change works. Here it goes. Goes somewhere to the center of the path, slows down, turns backwards, and then moves forward again on the path. So making any kind of timing variations is very easy with Playmation's time channel interface, because you can immediately make a change and see how your changes are going to be applied to the model as you start clicking across the frames. Now, if there's even a need to make, let's say for example, changes in the tilt or the scale of the model as the airplane is animating along the path, I can ask the channel, the time channel for the airplane, to show me tilt variations. So we want this airplane to kind of tilt back and forth as if it's having problems, landing or taking off. So we'll go in here and add in a few time changes by adding in a wobbly time channel. We'll do one other wobbly change there. Go on to frame number 30. So the airplane is going to kind of tilt back and forth as it goes across the path. Again, if I need to really see that, I can go through the camera's point of view and ask the airplane to be represented by its wireframe mode. And we'll start out from frame number 1. Here it goes as it starts animating across. It tilts a little bit to the left, tilts a little to the right, and moves all the way to the end of the path. Let's see how that looks playing back as a preview. Just like the action module, I can ask the computer to show me a little quick preview of how this animation is going to play back in real time. So it's creating it there. And here's what that motion looks like. Okay? There's the little tilt in the airplane as it moves back and forth. Notice how the camera is kind of like overshooting the airplane in the middle of the frame. The reason why that's happening is because you'll notice that we have the target of the airplane in the top view. Again, the green diamond represents the target right there. That is following a time channel of its own. So each independent part of things that are associated with the path can have their own time channel. So the artist can get very specific in terms of what kind of timing controls they want on any object or any light or anything else that's going to be traveling along the path. The few other things that I want to mention about Playmation is because we have all these modules that are multitasking together right now, if the artist feels like they want to make any changes in the middle of their creation process, they can immediately jump back to any of the other modules and make modifications, and then go back to the other module to see how, for example, a modeling change of, let's say, making the model twisted or a little larger is going to appear in their animation. So the serial thinking process that many of the other programs offer that just take you from sculpting to texturing to animating and rendering is not in Playmation. Playmation is completely modular in its design that allows the artist to be able to be in any environment and be able to immediately jump back to another environment to tweak out their changes and then come back in to the environment in which they were working in to continue their creative process. Now, we support, here's an example of a couple of advanced features and functions under Playmation. For example, under the character module, other than our textures that are available here, these textures are called procedural textures, and we provide 12 of them. You can also apply image maps onto the model. So the image that I have here right now, again, of using the picture, I'm going to attach a picture that we've already rendered from before onto the model. Here is, I can go in here and select the file that I want. And after I've selected it, now that picture is going to represent the coloring information stuck onto that vase. We support planar mapping, cylindrical mapping, spherical mapping, and all of those different mapping techniques can either be locked to the object's coordinate axis or to the world coordinate axis. First, let's see what the picture that we want to apply onto the model looks like. And the picture that I'm going to use actually is a rendering out of Playmation. So here's what that render is going to look like. Here we have it there. Now, this is the image that we want to map onto the model. And again, this is the image that I selected under my controls for texturing that's going to be stuck onto the face of the model. Let's see how that renders. Let's first save the changes and bring up the render module. So we've applied the image now to the model, to the picture model, and let's see how that's going to render out. So now again, the computer is going through ray tracing or rendering the model. Now, since this is going to take a little bit of time, I've done this before already, so let me show you what that's going to look like. The picture that we had before of that character has been stuck onto the model. So this allows the artist to be able to design any of their own textures that they want to assign and stick onto the model. So let's say if they want to photograph a texture of marble or wood, they want to wrap it around any of the shapes that they make. That is a feature available in the program. Playmation also supports the capability of attaching objects together to create a hierarchical object. Now, let me show you an example of what a hierarchical object looks like. So I'll bring in a model of a horse that I've done from before. Okay. Here's how the horse looks first in its bounding box format, and now here's how it looks with the spline representation with all the curved lines in it. Now you notice that the horse is made up of the different parts of its body: the tail, the legs, the neck, the eyes, the ears. Now the different parts of the body have been connected together in a hierarchical manner. And let me show you what I mean by that. For example, let's select the leg of the model, and we want to do just a little bit of rotation on the leg. We want to rotate it a little bit to the back of the model, or we want to rotate it a little bit to the front. After I've made that change, I now want to select a higher linkage along the linkage path. In this case, we're selecting the entire body. Now the leg is connected to the body, so if, for example, I was to rotate the body around, okay, you'll notice that the leg is gonna, and all the other limbs associated with the body are gonna follow as well. And this is very similar to, of course, the real world situation, that any kind of a character or any objects that are in some way mechanically connected together can be accurately represented in the 3D program. And every time in the action module, any kind of skeletal motion or spine motion, as we did before in the picture, are applied to any of the limbs, again, the hierarchical attachments of these objects are taken into account. So for example, if I was to bend the model, this horse's model's body a little bit by using spine motion, okay, first let's assign the spine. And then once we're in spine mode, if I'm to bend the model around a little bit, let's say a little to the up or a little down, let's bend it just a little bit up. You'll notice that the legs that are attached to the end of the model are going to bend up as well. Okay? Again, this is extremely important for being able to represent all the muscle and the attachments of the body that's necessary for doing character animation. A final point I'd like to make about direction is, where do you put your lights? Well, I'm going to add in a control point here, and up on the top we'll select the light button, and the little green star around that point represents our icon for light. Just like anything else in the environment, I can place the light anywhere I need, or I can have as many of these lights as I want. So adding another point in the environment, I'll put another light on the screen. Each light can be of any color, it can be of any intensity, or it can be of any type. Now what I mean by types is that, for example, you can have this light be a spotlight, it can be like a sun, or it can be like a light bulb. So the different lights with the different colors can also animate along a path, like what I've done here with this light source. let's see how that animates along the path. You can see the little green icon as it moves across the path. So you can also move the lights as well as changing their color or their intensity or their type. Finally, each light can have its own channel controls, just like everything else in Playmation, so that if you want to change the color, the coloring information is assigned to a path, or the type of the light, or, for example, the intensity of light. Again, all channel driven to give the maximum flexibility to the animator in terms of their lighting placement and lighting motion. This image on the screen represents a compilation of all the work that's necessary to produce a simple image like this. And notice the reflections and the highlights and the shadows that the computer has automatically provided into the image. Also notice that the curves that are around, for example, this picture's top are all 100% smooth. Now again, in other 3D programs that do 3D animation and modeling and rendering, you always have these polygon edges that appear on your renders. Again, that's because the models are represented by what we call finite models or finite resolution models, meaning that if you have any kind of a curved or circular cross-section, if you go close up to that curved cross-section, regardless of how many polygons represented, you always have this very edge-like look that's going to appear as you turn the cylinder or curved shape over on its side. Another thing that's very important about spline-based rendering is every time there is any kind of a curvature change from, let's say, something that's bulging towards the camera to something that's going away from the camera, all the errors that appear in other polygon-based programs that try to interpolate the shading between one polygon and the other to create smooth shading is not present in Playmation's renderer. Once again, because we are a direct ray patch intersection program and we never use polygons to approximate our shape. A final point about Playmation is considerations of price. Now, our program is $499 retail, but the computer that I'm running it on right now is about a $2,000 IBM PC. Now, for people that are interested in doing high-end computer graphics, most of the time they rely on computer graphics workstations that are often in excess of $100,000. Now let's say those workstations are about 10 times the speed and performance of an IBM PC. Well, that would mean that if I had 10 of these, I would be doing exactly the same speed at what the high-end platforms would do. So if each one of these is $2,000, 10 of them would make $20,000. That means that this program, along with 10 machines, is still 1/5 the price of the minimum computer graphics workstation.